So the nature of electrode. So one thing, like I said, inert electrode. Example, platinum, graphite, carbon. These are inert. These three are inert electrodes. So when you see the question, platinum electrode, graphite, or carbon, then the discharge of ions at the electrode would follow the position of ions in the electrochemical series or the concentration of the electrolyte. Now, but if the electrode is a metal of the salt or the electrolyte that is being used in that reaction, for example, if the electrode is silver electrode, and then let's say the salt is silver trioxonitrate 5. All right, so this is an electrolyte, this is an electrode. This is an electrolyte. How will ions be discharged? Now, for the cation is not affected. So, let's say you're talking about the electrolysis of silver chloride. Now, look at this. Okay, sorry, we have silver triazonitrate. Now, this is the electrolyte. You can see that we have this electrolyte and then we have this electrode that's a metal of the salt or the electrolyte that we are using. So if this current passes through this, remember this is aqueous. If current passes through this, you're going to have silver, you're going to have NO3, you're going to have hydrogen, and then you're going to have OH minus. Now, for the cation, between silver and hydrogen ion, which should be discharged at the cathode. Now, let's come here. This is hydrogen, this is silver. So between hydrogen and silver, which is more below in the electrochemical series? Silver is more below. So silver is going to be discharged at the cathode. So your cathode is not affected, whether it's concentration, whether it's nature of electrode. Your cathode is not affected. What is deposited at the cathode is spared. Well, I'm going to come to the place where I'm going to explain to you what is not spared when it comes to the cathode. However, for all of these things I've mentioned, your cathode is spared. All right, so now we have silver is going to be deposited at the cathode. Now, how about the anode? The nature of electrode here, if it's a metal, is going to affect the anode. Now, you have NO3 and OH. Normally, following the rules, this is not concentrated, whatever. This is not a concentrated salt. Between NO3 and OH, which one should be discharged? OH should be discharged, should be deposited. Because checking the electronegativity series, this is below. However, both OH, both NO3, none of them will be deposited at the anode. What is going to happen here is that this electrode, remember the electrode you use here is silver electrode. So both the cathode and the anode is made up of silver electrode. Now the electrode itself, the silver electrode, which is the anode, it's going to dissolve in the solution and form its own ion. So from here, we're going to have its own ion here. We're going to have silver ion here. So this electrode, this anode, the negative electrode, will discharge to form its own ion. And then remember that this ion is what? Positively charged. And this ion will move over to the cathode to be deposited there. Now, remember that we said that the anode dissolves. So it means that a part of that anode has been removed. A part of that anode has formed an ion. Hence, the mass of this anode will decrease. Remember, we're talking about the anode is an electrode, is the negative is the positive electrode. So a mass of this positive electrode, the anode, is going to decrease. Hope you got this. So if the anode or the mass of the anode that has been dissolved is moved over to the cathode, it means that the mass at the cathode is going to increase. So what happens here is that at the anode, the metal electrode dissolves in solution, forms its own its own ion, and this ion is carried over to the cathode to be deposited there. Also, this can happen for copper. Another popular one you find is copper. So the electrolysis of copper tetraoxosulfate using copper electrodes. So remember, this is aqueous. You're going to have copper SO4. You're going to have hydrogen OH. Now, what's going to be deposited at the cathode? Come here. Between hydrogen and copper, watch which one will be deposited. Copper will be deposited at the cathode. You get copper here. So the cathode, copper is going to be deposited. How about the anode? You have SO4 and OH. Which of these will be deposited? None. Rather, the copper electrode will dissolve in that solution to form its own ion, and this copper ion will be carried over to the cathode. This is what happens with nature of electrode when the electrode is a metal. Now remember I said that if the electrode is an inert electrode, if the electrode is platinum, carbon, graphite, you have no problem. It's going to follow the position of element or a position of ions in the electrochemical series. If it's going to follow position, or it's going to follow concentration, which I said affect just halogens in anions. Now, another thing you can have here is if mercury cathode is used. So let's clean this. So if mercury cathode is used, as electrode, now remember I said for your position of ions in the electrochemical series, we just say that the ions below in the electrochemical series should be discharged in preference to ions above. And concentration, we say concentration is going to affect what? Just an ion. That's what is going to be deposited in the anode. So we say that if the anode is a halogen and is concentrated, the halogen itself will be deposited. Then we talked about the metal. We say that the electron is going to dissolve in the solution and form its own ion, then it's going to move over to the cathode. Now, for the mercury is going to affect cation. So all of the while we're talking about nature of electron, we see that the ones that have a preference usually affect just the anode. However, we're talking about mercury, it's going to affect cations. So what do I mean? If I have electrolysis of sodium chloride, dilute sodium chloride, what's going to happen here? Dilute sodium chloride. Sodium and water. So this is going to form sodium and chlorine ion, hydrogen and hydroxy ion. Based on your electrochemical series, now we say this is using mercury electrode. Based on your electrochemical series, this is what's supposed to be deposited at the cathode. However, if mercury electrode is used, what is going to be deposited at the cathode is your sodium. I hope you got that. Now for this is dilute. So chlorine and OH, which one is below in the electrochemical series? OH. So this is going to be discharge. Now let me ask you a question quickly to be sure you're following. So I'm just going to clean this. Which of these is deposited in the electrolysis of concentrated sodium chloride? So I'm going to go A, hydrogen and OH, B, hydrogen and chlorine, C, sodium and chlorine, D, hydrogen and sodium and OH. So which of these is deposited in the electrolysis of concentrated sodium chloride? So at the cathode, what you're going to have at the cathode, you're going to have sodium and hydrogen. At the anode, you're going to have chlorine and OH. Now for the cathode, which is below in the electrochemical series, hydrogen. So at the cathode, hydrogen is going to be discharged. How about here? OH and chlorine. On a normal, OH is supposed to be discharged, but come back here. This is concentrated. And I said concentrated is going to affect what? Halogens. And this is a halogen. So between OH and chlorine, which is going to be discharged? Chlorine. So the answer is B. H and chlorine is going to be discharged. Now you're seeing that what's going to remain in the solution is your, now once you have hydrogen being discharged from a solution, that solution acidity automatically decreases. Once OH is discharged from a solution, acidity also what? Increases. So if you have OH discharged, if hydrogen is discharged, acidity decreases. If OH is discharged, acidity increases. So if hydrogen is discharged from the solution, acidity is going to do what? Acidity would decrease because hydrogen has been discharged. However, if OH is discharged, acidity will increase. Then this is the summary of what is being discharged at the electrode or at the cathode or anode in electrolysis. If you have any question and you would love me to answer on that electrolysis, after watching some other questions I've solved on the electrolysis, you can always ask in the comment section, and also you can join my student community where I send questions and help students prepare for their exams.